Today we're going to learn how to use the TI-84 to do regression analysis, which is part of Chapter 2, Section 1. And I'm actually going to do, out of the book on page 89, Example 4 has a biology example and then a shorter example with cars, and it's called the guided example. So I'm actually going to go through the guided example for Example 4 on page 89 of your textbook. So to do regression analysis, we have to enter lists, do statistical analysis on it, and do some plotting. To do that, let's make sure that the calculator is set up properly first. So the first thing I want you to do is go to Mode, make sure that you have Function set up, and that's really the only one of these that is important. It doesn't matter radians or degrees, connected dot, sequential simultaneous, whether you're doing real, imaginary, or polar imaginary. None of that matters for this. Just make sure that you're in function. We're going to go ahead and quit that. The next thing we're going to do is we have to enter the data from the table, which is speed and distance. And think of that as for a speed of 10, you go a distance of 4.2. For a speed of 20, you go a distance of 16.7. So you need to put those statistical lists in. You go down to this button right here that says Stat, and you open that up. And this is how you would enter or manipulate or deal with lists in your computer. So the first thing you need to do is check and see what you already have in your calculator. So under Edit, if you select 1 for Edit, you'll see that I have List 1, List 2, List 3, and it probably, I just have 3 lists in here. Now I need to clear those out so that I can enter the data that I am going to do for this example. So I'll go back to statistical, and you see number 4 is clear list. So you hit 4, clear list, then you have to tell it which list to clear. And if you do the blue button second, and then go down to L1 and hit enter, you've now cleared list 1. So let's go back and check and see how that looks. So go back to Stat, Edit, and you see list 1 is now empty. So let's go back and do that for list 2 and list 3. So 4 is to clear list, L2, enter, and then Stat 4 for clear list, second, L3, enter. And now if we go back to Stat, Edit, you see that all those lists are cleared. And what we're going to do is we're going to put the speed in for list 1 and the distance in for list 2, and that's as simple as putting in the numbers and hitting enter. So the first speed is 10, enter, and you'll see that 10 is entered as the first item in list 1. 20, 30, 40, 50, 60, and 70. Now to enter in list 2, you just go over to list 2, and you need to make sure that the 4.2 is across from the 10. So the 4.2 needs to be here, and so on. So we'll enter the first number, 4.2, and then 16.7, 37.6, 66.9, 104.5, almost there, 150.5, and then the last one that we put in is 204.9. Now, if you want to make sense of this data, if you want to graph the data, what we're going to do is make L1 the x value and L2 the y value, and we're going to plot these points, and when we plot these points, we're going to see what it looks like. So in order to plot points, I'm going to quit this. So you see the blue thing up above y equals, it says stat plot. We're going to go up and we're going to statistically plot or plot statistics, and we're going to select one just because it's on top. Since it's selected, we'll hit enter. We want to turn that on, and the type of statistical plot that we want. We just want the dots. Every place we have a piece of data, we want a dot. And we'll learn more about some of these other type of statistical plots. Now the x values are going to come out of L1, the y values are going to come out of L2, and I've selected as my mark just an open box. You could do dots, you could do plus signs if you wanted to, but that's just what I've selected. And since I've hit enter, I'm going to go ahead and quit that. Now, I'm also going to check y equals. I do not have any equations in there, so I'm covered. Let's just go straight to graphing it. And you'll notice when you graph it, you don't see anything because the first point is at 10, 4.2, and my window is set differently. So if you go to zoom and you scroll down, there's a Z stat button, and this is one of the ones that actually works really well. So if you hit 9 and then enter, these dots are all of the points that you plotted. So that's 10, 20, 30, 40, 50, 60, and 70. And if you look at that, you might say those kind of look like dots that might go along a parabola. And a parabola would be an x squared sort of an equation. So what we're going to do now is we are going to do some statistical analysis on those dots to see if we can figure out what the relationship is. So we're going to calculate, and you can calculate a bunch of things based on those lists. You can do statistical analysis, mean, median, mode, variance, all of that. But you can do regression testing. And when you do regression testing, you look at your data, you see what type of a function it might be, and in this case it looked kind of like it was a quadratic equation. So we're going to do quadratic regression. So go down to 5 and hit enter, or just press 5 and hit enter, and then it asks you what you want the X list to be, the Y list, frequency list, and so forth. And the only thing that you really need to put in there is make sure that the X list and the Y list are the proper list that you have put in, and then you just keep hitting enter until you get to calculate, hit enter, and now it tells you the equation y is equal to ax squared plus bx plus c, where a is 0.042, b is 0.004, and I'm rounding, c is 0.043. So if you were to write that, you would write 0.042 x squared plus, actually it would be minus 0.004 x plus 0.043. And your r value or r squared value tells you the correlation. The closer that number is to 1, the greater the correlation. So the fact that it is nines to a number of significant digits tells you that that is a really, really close correlation. So now that you have that equation, part A tells you to draw the scatter plot. We did that. Part B is determine the power function used to model the data, and that's what we have here. So you could write that out. But part C says predict the braking distance of the car going 80 miles an hour. Well, now that you have an equation, you can just put 80 in for x and see what it is. But do you really want to type in all of those long numbers? So let me show you a shortcut that goes along with that. So if you go back to y equals, let's put that equation in for y1. And this is kind of a little bit tricky, so you're going to need to follow me here. If you go to variables, or VARS, click enter, and you want to deal with statistics because that's what we're working with. So you'd go to statistics and hit enter. And what we did was we just generated an equation. It was a regression equation, and that is actually stored in the memory. So if I hit enter on the regression equation, it now puts all of those numbers, and they don't round them, all of these numbers in for ax squared. Remember, a was 0.042, and b was negative 0.004, and so forth. So now you have the equation in as y1. So let's graph that. And you have your dots, which are the actual data points that you entered, and then you have the equation that you got through regression analysis, and it looks like that's a pretty good fit. And what you'll find is it does not always hit every point perfectly because it actually goes through some pretty painful math to calculate that. So now that you have your lists put in, your points plotted, your regression analysis done, and your equation entered as y1, part C says predict the braking distance of a car going 80 miles per hour. So let's go ahead and quit this. And you could go into your table over here and scroll to 80 if you wanted to, but the easy way to go is just pull up y1 and in parentheses put 80, and that'll give you the value of your regression analysis equation when you're going 80 miles an hour, and it says that the distance will be 267.643 or 267.6 because all of the distances are in tenths if you want to be consistent. So that is the process that you would go through for regression analysis.